Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Your co-host, Rich Gear here, and we have a fishy story to tell you today. Is that right, Doug?
That's right.
Or is this the official version? Or the unofficial version?
You keep it up and I'll punch you out.
And then I'll be finished. Okay. All right, that's good. Sorry, we had to give him the punchline.
That's right.
Or two. So, Doug, what's a fishy story? Okay, we're continue on.
Yeah, I'm going back and revising the book Revolution Against Evolution. What I'm going to do is probably have a addendum or appendix that's going to be on the internet that I'm going to put out there as an update for each of the chapters in the book, and I want to be able to bring the book up to date. This is 20 years old now.
What's amazing, though, and we've taught the several chapters that we've gone through already, is that although there are things that need to be updated and some things that are really obsolete, a lot of it has really held up pretty well, Doug. That's what
right, and a lot of things
amazing.
that was predicted back then has really
have come to pass. Yes,
come to pass, and I'm gratified by that. And it's not really become that obsolete of a book. I got a few little things in there that are gone by the wayside, but I think for the most part it's been held up pretty good.
Yep.
And one of the chapters was about animals that could not have evolved, and there was a number of things in that chapter about fish. And if you take a look at the fish, in many respects, they have some characteristics that are actually more complicated than even human beings, because the DNA content of fish and some fish and amphibians, maybe because they live in the water, and this was Watson that brought this out, and Watson and Crick, that the DNA content of some fish and amphibians is about 25 times that of mammals and humans.
So instead of evolution based on their scenario, since the water animals came first, we would have, even under their scenarios, devolution.
Evolution, yes.
Because we've lost genetic information. Well, that doesn't really... What do people say about that, Doug?
What I'm saying is that I don't think that they even take that into account, but what they... it's something that just goes over the top of people's heads and as non-data from their standpoint.
The glazed donut response,
But if you take a look at the design of fish, and they have actually a feature that I don't think that there's anything that we have that is duplicated in that, and that's the gill structure where it extracts oxygen out of the water.
Mm-hmm.
If we actually developed some sort of breathing apparatus that did that, the guy who invents something like that would be a millionaire, because then you could actually explore down the bottom of the ocean. And
that would be, well, the pressure still would be something you have to deal with. But
right.
But you're right about that. I never really considered it in that light before, because water is a very stable compound based on the merger of two unstable compounds. Mm-hmm. You got oxygen and hydrogen,
right.
And it's kind of amazing that when they come together the way they do, two hydrogens to one oxygen, or is it the other way around? I was going to
H2O.
Yeah. Anyway, it's like, you how does something that's very unstable, volatile, if you will, yet when they get together they become so stable that we don't have a way to extrapolate that oxygen. We don't have the way to pull it out very easily,
right.
But natural, all the animals in the water do that naturally. Have they ever studied some of that stuff?
Well, they don't extract it out of the water molecule.
Well, how do they do it?
Oxygen in the water that they pull out, and so it's
okay. But how does that happen?
And it's the structure of the gill that does it. It actually filters through the gills, and it absorbs the oxygen that's in the water. And I've not really seen an article written that has talked about how that actually works.
I've never heard of it. But I've never thought of it. The way you're explaining like that, I go, to me that sounds like, they're pulling oxygen out of the water. How do they do that?
And you have
know
all
they
kinds
do.
of creatures in the ocean that are different from fish that
Yeah,
live in
starfish, seahorses.
jellyfish. When when we went to the Houston Zoo, while we were down in Houston, and they have a real nice aquarium in that zoo. And one of the first exhibits that we saw was this cylindrical aquarium where you had these jellyfish. They were going sort of like this, you
Yep.
know, where and these creatures, according to evolution, are primitive creatures. They're not even, they don't even have a backbone or a cord.
Right.
They're not chordated. And so they're just
They're invertebrates. They just,
invertebrates, but the clams and the sea urchins and the sea anemones and all these other creatures of that sort, and they're actually quite beautiful and to look at.
Yep.
They
Just don't step on some of those with bare feet.
That's right. Yeah.
Boy.
But it's really was fascinating to me that all these different designs of creatures that live in the water deal with the extraction of oxygen out of the water, and then the evolutionists have to figure out, well, how do you bridge that gap from the water environment and go into the air-breathing environment? You have to have a whole different type of design for a lung in order to breathe. Now, there is such a thing as a lungfish, and I saw one of those in the aquarium. And,
Yeah.
What happens with that is that it has a lung as well as the gill apparatus, but the lung allows it to live out of water for a period of time, and it actually it estivates. Which the estivation, and what it actually does is it, as a pond dries up, it's sort of.
Just a pond
it's like
what it's going to do, huh?
It breathes air, and it's actually a form of hibernation until the pond gets.
Okay, so so he normally breathes through. He does the gill thing,
Right.
like normal fishes do, but he actually has a lung along with the gill apparatus. So there's the apparatus, the gill apparatus, whatever that is, which I don't know what
Right.
it is, and then he also has a lung on top of it. Now, would evolutionists say that this lungfish is evolving into a
Well,
land
yeah,
animal?
they would make the lungfish into a transitional form.
Right.
But I don't see that as being a very viable option. The lungfish is really a specifically created creature that does what it does.
Okay.
And for us to, and it's sort of like the coelacanth. It's another example of a fish that they're trying to make that in a transitional form because it has
Yeah.
lobe type of fins that they say, well, this is on its way to becoming feet and limbs.
Right. So
Fish
yeah.
evolution has to account for each species of fish that you find out there.
Well, now you got the other problem with evolution. It's always had this convergent evolution.
Right.
Okay, because like you said, starfish, the jellyfish, regular, finned fish. You've got you got the mammalian creatures, the whales.
The sharks and the...
Yeah, you got the bony fishes, the cartilaginous shark. And they're all. How about the ones the ones that glow in the dark at the bottom of the oceans?
Right,
The fluorescent ones or phosphorescent ones.
Right.
They're all different kinds of these things, and they all have this ability of taking water and processing it and turning it into oxygen. I think that's fascinating, Doug.
Oh, extracting the oxygen out of the water.
Yeah.
Is what it's doing. It's not chemically separating hydrogen from oxygen.
No, I'm not saying it's doing that. I mean, of course, I don't know what's the difference to me. Either chemically or swishing it around or whatever.
It's dissolved. Oxygen is dissolved in the water. It's not. Not.
So is the water then
The water is H2O.
I know. So the oxygen that's in there stays in there then.
Right. It's.
So where's the oxygen coming from then?
Well, it's just like from the atmosphere. It's dissolved within it. So
Okay, so it's from the air
Yeah.
that comes in rather than from the water itself?
It's sort of like dissolving salt in water.
Yeah, okay.
But in this case, the oxygen is in it. It's not separating oxygen from hydrogen to.
Okay, see, that's what I didn't understand. So I said, you said you've never written any, or seen anything written about it, so I haven't either. So how did you know what you knew, how'd you know about that then?
Well,
Somebody must have
because,
written something, huh?
I do know that it isn't, I know what the chemistry is
Okay.
of water,
Yeah.
and that it isn't that easy to separate the hydrogen from the
I
oxygen.
thought it was impossible just about, okay. All right.
Well,
can
you
do it,
actually
but-
do it with electricity.
Yeah, you can do- okay.
electrodes, and it separates it.
Is it? Okay.
And so when you have.
How did they do it from way in the bottom of the ocean? So oxygen from the atmosphere gets all the way in the bottom
Yeah,
of
it
it?
does. When you have the wave actions and
Mm-hmm.
wind actions, it just.
When you think about that,
mixes
that's
it all
like,
up.
to me, out of God's providence. Think about
Oh,
that,
yeah.
how that moves in like, that's terrific, Doug. Well, if, we do have the water's 3/4 of the earth right now, Hey
Right.
Doug, I thought of a subtitle for our show,
What's
The
that?
Dawning of the Age of Aquariums.
Oh, is that right? huh?
Well, I just thought, this came to me, I just thought,
The dawning of the age of aquariums. Oh, cheers. I'm not going there.
okay, all right, I just thought I'd throw that out for the fun of it.
In my book, I talked about some examples of fish.
Yeah, I was gonna get to that, Doug. What probably is your most favorite one? I mean, I wanna tell you, there's one of my favorite ones, and see if this is one of yours. It's that anableps one.
Yes, the anableps is.
I love that
is
guy.
fun because, and when I was in this is years ago, I was in the Shed Aquarium in Chicago, and they had some of the anableps.
Do you know the Pruss pet shop has
Really?
anableps in there?
They do.
They
Oh.
do. I saw them. I was in there.
Well, they're kind of
They are
active
the
fish.
coolest.
They go.
They are the
all over
coolest
the
looking
place,
things
yeah.
ever.
And they're on the surface, and the top of the eyes are split in half.
Yeah.
And the top part of the eye is made to look above the water, while as the bottom is made to look below the water. And so they can see creatures, birds up above that could be potentially preying
Right.
upon them, as well as their food source down below. And so I didn't know that Prue's Pets had.
They have them. I was shocked. I looked at that, and they also have the archer fish?
Archer fish,
The one that
yes.
shoots the water?
Oh, yeah.
They have one of those.
They should. Oh, they're going through it. You see that?
Yeah, they spit at it.
Like shooting at it. Yep, they do that in the wild with bugs. They'll actually shoot them off of like tree branches and things like that.
They must have some pretty good aim to do that.
Not only that, the refraction of the water is a problem for them. So how do they figure that out? Now, did you say you have anableps in here too?
We're out of those right now. They're really cool though. They have 4 pupils. Basically, they can look above the water and below at the same time.
Wow.
Oh, look at you. Solid. Just a little bit.
Roger Pruce is in my Monday night Bible study.
Maybe that's why he's got it. Maybe you saw it in your
Yeah.
book.
They're just really cool fish. The archer fish has a little narrow groove in its mouth that shoots out this water.
And I saw him do it. He zapped. It was really cool to watch. They shot the water right out
Yeah.
and zapped something, right? And that was very, very
I'm gonna have to
fascinating.
check that out. That's pretty cool.
Yeah, I was going to tell you that. I kept forgetting about that.
Be a patron of Pruce Pets. They're
Yeah.
pretty cool.
Of course, we're it's the local area here in Lansing, Michigan, but
Yeah.
that's where we're doing the film here. But it's just Pruce Pets. That was the coolest thing. When I went in there, I saw both those fishes in there.
Then there's the anglerfish, which has a little appendage up above its mouth that looks like a bait.
Yeah, it looks like a fish.
Like another fish.
Another fish, yep.
And The decoy fish was another one that is a similar principle, is that you have a little appendage on the fish that becomes the bait, but then it causes it to the potential prey to try to prey on the prey.
It's prey on the prey, yeah.
Mhm.
They'll come out for the little fish, then the big fish says, hi, snarf, you know?
Yeah. And, there's a lot of puzzles with fish, like the wrasse, which is a cleaner fish. And the big fish will allow the little fish to go and clean its teeth.
Well, it's like the fish that is, maybe you're talking about the same one, all those ones, what are the ones that go around sharks' teeth? And they're always cleaning their teeth out.
Yeah, that's what it is.
Is
yeah.
that the same fish? Okay.
And so, I was in this aquarium in Houston, and they had all kinds of these fish, but we all love the Finding Nemo story, and that to have a clownfish, which is orange,
Orange, yeah.
so brightly colored, and yet the way it survives is it hides in the anemones. For some reason, the anemone doesn't bother
Doesn't
it.
bother it, yeah.
And how that little mutual relationship was worked out.
You see a lot of symbiosis in the ocean.
Yeah, you do, yeah.
And it's there's just a lot of that kind of stuff. I always think is fascinating too, Doug, is the fish in the oceans are always the brightly colored ones. The freshwater fish are kind of dull looking. Good eating, but they're dull looking. They don't look very pretty for the most part. But the ones in the ocean, they're the ones with the brightly colored blue stripes, blue neon tetras, and all those wild, the clownfish, bright orange fishes.
Yeah.
They're always out there. But Doug, I mean, and that's basically what it is. Does the salt, when you adapt for the salt, does that bring the color out more? I mean, I have no idea. I just don't. There's so many things.
Well, you'd have to understand the mind of the creator in this particular.
And I don't know why.
And a lot of
it's
things,
like that, yeah.
where you have a lot of color, it's just because the Lord Himself decided to do it that
He's
way.
a creator. I think he likes beauty, and he creates color, and he gives us the ability to see color. I always think that's kind of neat. But Doug, why could none of these fishes have evolved?
Well, what you have to do is to figure out what they would have evolved from. And what you do is have an imagination going on of what this pre-archer fish would have looked
Okay,
like.
all right.
And if while it was making, and it's another case of either something works or it doesn't.
Oh, okay.
And so while it's making this little groove in its mouth, could it have done it gradually until all of a sudden one day the fish decide, well, let's see what happens if I
shoot a
spit
bit
at
of water
this,
at that fly up there.
Yeah.
But see, the problem is, evolution forces you to anthropomorphize
Right.
and put almost human thoughts to things that have no ability to think that way. I mean,
Right.
That's why you have to always appeal to, for instance, the properties inherent in matter. But the properties inherent in matter do not evolve upward, Doug. The properties inherent in matter do not self-organize and become more complex. They always go the opposite unless there's some kind of program to start with and some energy coupled with that program to generate it to go in a certain way. And that's what always is so problematic about the entire evolutionary fish story.
Right,
That's
and
what I
it's
call
a way of managing information is what evolutionists needs to explain, because the information that goes into the creation of these creatures is really stupendous. Like what I said, and it doesn't follow a gradual evolutionary line. It's
Well, that's why a lot of them have retreated to that punctuated equilibrium, or the Goldschmidt hopeful monster theory, which is basically punctuated equilibrium. Yeah, there's some differences, but in other words, it just suddenly happens.
Right.
I mean, I'm being simplistic, yes, and they'll say, well, it could take a period of several thousand years for it to. I said, unless everything works on these creatures, Doug, nothing
Right.
works. And there's no gradual scenario you can even postulate to make it figure out what kind of graduated things could have come to that thing where you'd have a fake fish on the top, the
Right,
decoy
yeah.
fishes, or the groove in the mouth, or the double-sided eye. That to me is, the dye itself gave Darwin conniption fits. Now you got an anableps with a double eye. Where you could focus as underwater as well as focus as above water. There's no plausible scenario that even makes any sense to me.
You know, there's one creature in the ocean that has an eye that's very much like ours. And
The octopus, right?
It's the octopus.
Yeah. We didn't even talk about those guys, yeah.
And what's interesting is that octopus and the lobster, I think their blood is blue.
Is it really?
It's not red.
So they're the royal fish, huh?
I guess so.
Ultimate blue bloods, you know?
Pale of blue bug's blood, right?
Blue blood, whatever, yeah. So their eyes are like ours then, huh?
Yeah, and it's kind of interesting.
Wait, the lobster's eye's not like ours, but the
No,
octopus is. But
octopus
they both
is.
have. Now, what makes it blue? Are they have
Well, it's
cyan
actually got copper base.
base instead of iron based? Wow, how does that work?
I haven't ever had an evolutionist explain this at all. You know, how do you figure that these crustaceans of this sort have blood that's
An
blue?
octopus has an eye similar to a human mammal, mammalian creature, mammal, who lives above, not in the ocean, but it has blue blood like a crustacean.
Right, yeah.
See, this is to me the variety.
I hope I got that right, but I think that I'm
Pretty sure on that one?
pretty sure
I
on
didn't
that.
know that, yeah.
But you know, and then the 8 arms of the octopus.
I mean,
of
the
course.
10 on the squid.
Yeah, it's just a strange creature.
So Doug, what's your favorite one of all the ones, the most anomalous fish, do you think? Or the one that would seem to you to be the most hard to explain by the case of evolutionary biology?
Well, I think the anglerfish is one because of its strange life cycle.
Okay.
The male of the species doesn't eat, but it connects to the female in such a way that it shares its bloodstream.
Really?
And so there is that sort of strange
Wow.
life cycle that is with the anglerfish. I don't think it's duplicated anyplace else.
What's it do? How does it attach itself?
Well, apparently there's just some sort of mechanism built into the anglerfish that it attaches, and it's much smaller than the female.
Oh,
And
okay.
So it's sort of like the black widow spider, you know.
Does the female eat them?
I don't. I think after the male gets done doing his thing, it dies. So.
Really? That's a heck of a lifestyle, isn't it?
Yeah. Well.
Well,
You know, there's going to be a number of things I'm going to ask the Lord when I get to heaven, and that's one of them. You know,
I get
why
these
did
things
you
around these
design
questions.
it this
Yeah.
way?
I'm thinking about what I'm going to ask from the Lord. Then I get up there, and I have a feeling I may just forget everything when I see the presence of the
That's
Creator
right,
of the
yeah.
universe. Hopefully, He'll let us keep some of our presence of mind to be able to ask some of these great questions, or we'll maybe just understand them. We'll just say how it works, and then we'll go on to other things. I don't know. It's
Well, I imagine, one of the things, when you came to know the Lord, I told you that someday you'll have the opportunity to create a painting and take 1,000 years to do it.
Well, it may not even be a painting in those days. You might be. I mean, I think about that, Doug. It's just, things will be made clear. I mean, the Scripture says, "Eye has not seen nor ear heard the things that God has prepared for those who love Him." And I'm going, if this creation, which we know is broken,
Right.
this creation which is fallen, this creation where death and dying is a part of it because it's under judgment, still has such beauty, such majesty, such mystery. What's it going to be like in the age to come? You know, we deal with creation stuff for that reason, Doug. It's like we look at the physical universe and see how amazing it is. We don't use the physical universe to define the Creator, but we can look at it to help reveal Him. And the Scripture is very clear that that is what it is, one of the reasons that it is there for, is to reveal Him. You know, I mean, the Bible is very clear. I mean, it is the glory of God to conceal a thing and the glory of the King to ferret it out. And He has made us inheritors of kingship. We are going to be kings in the age to come, and we are actually right now. So it's fun to start figuring things out now as much as possible.
Another favorite fish, Rich.
Yeah, oh, he's got another one. Okay.
Is the lionfish.
All right.
And this creature, is got all these appendages that float around.
Oh yeah, it's a very beautiful fish. Yeah,
and it is a beautiful fish. It's a very interesting fish. It's also poisonous. You don't want to go grab it and catch it, because it'll sting you, and you might die from it, I guess. But that creature, again, there's nothing much like it. And then seahorses and pipefish.
Yeah, those are wild things.
Those things are very interesting, and I got some video of that. And but the pipefish in the aquarium that we saw, there were little tiny things. I thought they were big, long fish, but they were just little tiny things like that. And so there's just nothing like it. And the male of the species are the ones that take care of the eggs.
You talking about the seahorse or the pipefish?
The seahorses, yeah.
Yeah, seahorses, the male does that, yeah.
I think the pipefish does that
as well.
I think they're similar in design.
Okay.
But anyway, I think that God created these creatures. I think the evidence is for their creation is just marvelous. We'll see you next time on Revolution Against Evolution.